recording me, and now I have a pause. Okay, hello everybody, and welcome to this live meeting. Today's topic is building solutions using Windows Embedded CE 6.0 R2. This live meeting is for trainers that have already taken the training course and would like to be updated on the materials that we're releasing for CE 6.0 R2. A number of things to start out with. First, the goals for this class update. What we tried to do is we tried to kind of freshen up the material and use the existing material as a base for that for this class. We didn't want to make major changes. The material still is based on Windows Embedded CE 6.0. So instructors that are already teaching the course won't have major course flow changes and things like that. The update we're also trying to do with the update is to reflect changes that have occurred since the materials were initially released about a year ago. This would include things like ST1, R2, any QFEs that may have affected the materials. Not too many of those though. We also wanted to create an instructor manual to add value to the course for the instructors so that it would be a lot easier for them to add value to their students. This was accomplished using notes, the notes field in PowerPoint. So you can see I have PowerPoint open in edit mode for the purposes of this presentation, and you can see here I have instructor notes with basically a tag in the notes field. We created macros that allow you to strip those notes out and build a student manual, or leave those notes in and build a instructor manual. All the files that have been created are available in source form so that you can actually make edits as you see fit. You can add additional notes, those kinds of things. And then finally, we wanted to update the materials for any errors, any formatting inconsistencies, any clarity, some minor enhancements, and also to apply a standard theme for all the graphics. And we've accomplished that, as you'll see as I go through the slides today. This slide is the first slide that you would actually see in a real presentation, and the idea behind this slide is that you'd have this slide up when the students are entering the class. Now, as I go through the slides today, there's 371 different slides for this class. Some of the slides I'll go through very quickly, since this is really just an update for existing trainers. And other slides I'll spend a little bit of time on, but you'll notice that there's actually 5 slides prior to this 6th slide, of course. And those 5 slides are all hidden slides for the purpose of building a manual, a student manual and an instructor manual from the exact same PowerPoint presentation. So in switching PowerPoint to a notes view or printing it as a notes page, then you'll actually see the slide information at the top of each page and the notes at the bottom of each page. And in order to create things like table of contents, title slides, or title pages, and things like that, we've inserted some slides and actually hidden their content during presentation mode. So as you see here, we have a slide, the first slide for the presentation. Okay, with that said, let's kind of go through the slides, and what I'm going to do is I'm going to point out some of the changes that we've made in the materials as we go along, and hopefully give you all the information you need to make it easier to come up to speed on the new material and to use the new material for presentation purposes. Okay, well, the first thing I want to talk about is you're going to download all the files that you need in order to make this presentation. So before we even proceed with the slides, let me show you briefly what you have in the way of files that you're going to receive from the download when you at the Windows Embedded Training site. So what we have is you'll have a directory, and I'm not sure what the directory name will actually be, but in that directory you'll actually have a number of files. You'll have a lab files folder. This folder has all the files that are needed for the students to complete the labs, including things like text that the lab manuals ask the students to type in. That text, it just makes it easier so there's less chance they'll make mistakes and things like that. And then, of course, you have a lab manual folder. This folder has the Word docs and the PowerPoint docs for the entire lab manual. You could distribute the PDFs, or you could print the PDFs to a manual and let the students use that manual. But in addition to that, the Word docs are there as well, so that way if you wanted to add any content, change anything, make any edits, those files are there for you. Now the next folder is new to this training course. We actually, when I was mentioning the class updates, one thing I failed to mention was we decided to go ahead and create videos for each lab so that the students would be able to play a video, or the instructor, at your choice, would be able to play a video and either review a lab or maybe even play the video prior to doing the lab with the expectation that there'd be less chances for errors in the lab. Maybe make the class go a little quicker, especially if you have a really big class, that kind of thing. But anyway, we have videos that walk through each lab step by step. Those videos are recorded at 1024 by 768, which is the resolution that I'm presenting to you today. Those videos are video only. There's no audio, so it'd be up to you as an instructor to play through those videos, watch, point out different aspects within those videos, and basically lead that session. Okay. Then we have 4 other files here that are of interest. Let's forget about this temporary file here. We have 4 other files of interest. We have the PowerPoint presentation. The presentation is now contained within one PowerPoint file. That PowerPoint file is saved in 2003 compatible format. I'll be presenting to you today in 2007, but this one is actually in 2003 format. All the modules are contained in one file, and I'll explain more information about that PowerPoint file as we go through the slides. Then we have 2 other documents here that have been prepared for you. One is the instructor manual in PDF format and the student manual in PDF format. Now, you don't see a source for these 2 PDFs in any kind of doc format. That's because, again, we use the PowerPoint slides as the source material for producing these PDFs. So these PDFs are just generated files that we've already provided for your convenience. If you're going to make modifications, then obviously you'd have to regenerate these PDF files. And then finally, we have this README doc. This is a doc that I put together to maybe give you a few pointers, things like that, for the files that you'll be receiving here. An explanation again for what each file is and that kind of thing. So let's go back to our presentation and start doing some introductions here. So this slide that you see here is a slide that we're going to come back to give you some type of flow for the presentation. And it basically just gives you a topic slide or a module slide that introduces that we're moving on to the next module. And right now, of course, we're in the introduction, which is why you see the introduction highlighted here. Now, once you're in a module, you'll notice that on the next slide, the module title actually moves to the top of the slide and continuously is presented at the top of each slide. So you'll notice that as we go forward. Now, the first slide of every module is in this module introductory slide that lists the topics that are going to be talked about in that module, with the final topic of every module being a review slide that lets you review as you see fit. And of course, there's instructor notes here that explain much of this as well. But the topics for the introduction section are simply a welcome topic, a Microsoft Embedded OS offerings topic, a who and what is this course targeted at topic, and then, like I say, a review topic. So let's move on to the review topic. So I'm going to be presenting in edit mode, so therefore I got to get used to my keys here. Okay, so the next thing you'll see is as you move to each topic, the first slide of every topic is that topic with a screen with a little window that fades in within about 2 seconds. The screen will fade in and provide information about that topic rather than having to switch screens, but at the same time still giving you flow. So the things that we're going to discuss in the welcome topic, which are the things that you've discussed in previous classes, would be things like your building hours, your class hours, where your restrooms are located, parking, web access, meals, refreshments, smoking, and recycling, things like that. And then, of course, the next slide moves into the first introduction, or the first slide after the topic introduction slide. So in this case, it actually is introductions, where we'll actually go through and let the students do introductions, their name, company affiliation, title, job responsibility, programming experience, previous Windows CE, Windows Embedded CE experience, and expectations for the course, so you can gauge, how you might add more value for the students throughout the week. But at this point, let me introduce myself, since I haven't done that yet. My name is Randy Moore, and I've been working with Windows CE for about 10 years now, and I've done this presentation thing quite a few times. I do a lot of training, a lot of engineering with Windows Embedded CE, and hopefully I'll be able to give you some good pointers today on how you might present this material and make your job a little bit easier, or at least a little bit more complete. Okay, so with that said, let's move on to the next slide. The next slide talks about the course materials. For this class, those course materials really haven't changed from the previous class. I went over the files that you'll actually receive from the download site. In addition to that, you probably want to talk about the web-based evaluation to your students so that they understand that process as well. The hardware setup for this class is the same as the previous class. You'll have a development workstation, Visual Studio 2005. You will have Windows Embedded CE 6.0 R2 installed for this class. Although none of the labs actually make use of CE 6.0 R2, you probably want to have the latest materials installed. And then for this class, we specifically chose to use the software device emulator as we did in the previous class. The labs from the previous class are the same labs that we're doing in this class. They have minor modifications for any formatting, but no functional changes. The labs have all been recorded or have been set up to walk through with Vista. The choice was made to use Vista as the basis for taking screenshots and those kinds of things. So you'll see that on a number of the slides that actually have screenshots throughout this presentation. But of course, as with the previous class, you can set up the labs to run on real targets, as many of us do, and it doesn't take much work to get the labs to work on the remote target rather than the emulator, with the obvious requirement that you now have a device that has to be booted and connected to Platform Builder. Okay. Next slide here. So then we move into the next topic. And what would happen here, if we were in a real presentation, would be that you'd see the topic, Microsoft Embedded OS offerings that you see there in black. You'd actually see that topic highlighted in black with the other topics grayed out. And then slowly, at about 2 seconds, like I said, this screen that's on top here would fade in, and you'd now see that we're going to talk about the .NET Micro Framework, the Windows Embedded CE and SKUs, and so forth during this Microsoft's Embedded OS offerings topic. Now, the choice was made to move this topic into the introduction due to the fact that it was really more of an introductory type topic. So the topic is basically the same, but it's been moved into the introduction. Now, another thing that we've done throughout the material that you'll notice is try to remove duplication of items, and also to try to minimize the number of slides that are somewhat repetitive. In other words, if we're trying to talk about a topic and we can show that topic on one slide rather than 3, then you'll see that some of that's actually taken place. We've actually minimized the number of slides so that it's more of a instructor talking point to talk about different items rather than just maybe move between items and highlighting a new item on a new slide. But anyway, this topic is very brief. And here, what you want to do is you want to talk about what Microsoft's other offerings are in the embedded OS space, so that students that are unaware of those topics may be able to go get more information. But of course, you're not going to talk about any of these in any detail other than Windows Embedded CE, because that's what your students are here for. Okay, so with that said, what we have is we have one slide on each of the I would say OS offering categories. And the way I categorize those, and you'll see some things in the notes here about this, is that we categorize things in 3 different categories. The micro framework kind of stands alone. Then Windows CE and Windows Embedded CE based OS offerings. And then finally, desktop offerings, so things like Vista and XP would be in those desktop offerings. So we have a slide on each one of those categories, if you will, and the first one here is on the .NET Micro Framework. Now, you'll also note that in the instructor notes, there are a lot of times links to information on MSDN, so you can get more information about those topics as you see fit. Sometimes links are presented for students, sometimes they're in the instructor notes. It's not easy to make a decision about when to keep information out of the student notes and put it in instructor notes, but we've kind of taken a stab at it with this course, and of course you can move things as you see fit when you actually produce your student manuals. And you can also provide the information that's in the instructor notes, which is many times provided so that you can add more value by saying, if you want to, you can check out a link, and here's a link for the micro framework. But at this point, it's really a slide to introduce the topic, tell your students, yeah, you can get more information on this if you want by going to the Windows Embedded landing page, and from there you'll find links to the different Windows Embedded OSs. Okay. So the next slide talks about Windows CE very briefly. You of course are going to tell your students that they'll be able to talk about this. You'll talk about this in much more detail because that's what this course is all about. But for now, you're offering them some information that allows them to make a comparison between the other embedded OS offerings and maybe ask any preliminary questions. Okay, and then finally we have a slide on the embedded version of desktop operating systems, and that would include things like XP Embedded, XP POS, Vista for embedded systems, both business and ultimate. And then we have a slide here, same with the .NET Micro Framework, you'd point them to the embedded website to get more information, or maybe the distributor, or maybe you could take it offline, depends on your class and your business. Okay, now we move into the final topic of this course introduction, which is the who and what is this course targeted at. And the who is those that will be involved in the creation and customization of the OS image for a device. That would include people like BSP developers, OS builders, device driver developers, quality assurance people, test people. All of these kinds of people are the core people that this course is really targeted at. Primarily targeted at engineers that understand embedded systems and want to use Windows CE to build some embedded systems. Now, hopefully they know that before they get here. But I think this slide is a good slide to make sure that you're setting the expectation for the class. Another thing that we have some other slides that point this out, but one thing you want to make sure of is that your students are here for OS image type engineering and not application engineering, because the class really is not about application engineering, even though we have one module. As we'll see in module number 9, we have information on applications. We even do a lab on building a managed application. Okay, next slide is the what. The what is simply what the who does, and that is the process of creating a product OS image, which would include creating the OS design, locating and creating VSPs, creating custom drivers, customizing OS design, building the OS SDK and application development, testing and deployment. But again, you want to point out that the application development is very light in this class. The reason we have the recycle icon or the double arrow icon that looks like a circle there after many of the topics is because it's a good idea to iterate on this slide that, just make sure your students are aware that these topics are not just, here's a bulleted checklist, go down these topics and you're done building your embedded device. While I think probably most engineers realize that, it does seem like sometimes people have a impression that building a Windows CE device for some reason is so much easier than any other embedded device that's ever been built. But there still is quite a bit of an engineering process to it, and you'll want to convey that throughout the course for different components, different pieces. Obviously, some of the pieces Microsoft does supply out of the box, and that's one reason that we choose Windows Embedded CE. We'll talk a little bit more about that later. Okay, so next slide is prerequisites for the class, and these aren't really hard prerequisites. They're simply helpful prerequisites. They're prerequisites for the people that the course is really targeted at. That would be things like programming experience in C and C++. If you're going to go through the labs and you're going to understand the labs and you're going to understand some of the topics that we talk about in this class, then for sure you're going to want to make sure your students understand that the class is targeted at people who have this type of knowledge. So programming in C, C++, some knowledge of Windows operating system internals definitely helps. Win32 API, of course, helps. Device driver development and embedded operating system experience. All of these things help and are not necessarily prerequisites, but definitely helpful throughout the course. Okay, and then as I said, each topic or each module ends with a review slide. At the end of each module, you see this slide. You have a chance to recap any questions that have been asked, maybe even just talk about, okay, well, we're going to answer this question in the future, but let's just make sure we don't lose track of this question. Maybe put it up on the whiteboard in your classroom or what have you. Okay, so the next thing we're going to do is we're going to move on to the next module, but before that, I'm just going to take a short break, and I'll be right back. Okay, well, let's continue on. So we finished up here on this review slide for the course introduction topic, or the course introduction module, and now we're going to move into our operating system overview module. As you can see here, we have another hidden slide, and this slide would be the title page in the manual that would be printed for that module, the operating system overview section. So the next slide you'd actually see in presentation mode would be this slide here, which is the course outline slide. Took PowerPoint a little bit of time to catch up with me there, I guess. Okay, so, and this introduces the module that we'll now be entering. So this is kind of your intro slide to module number 1, which is operating system overview. Now the slide that you didn't see, the hidden slide, if you did thumb through those in edit mode, you'd see the slide, and this information is actually the information you'd see if you were in the manual at the top of the page, or if you were in Notes View. So anyway, let's move on to what's actually being presented, and that is the operating system overview module. Okay, so in this module, we are going to look at the characteristics of Windows Embedded CE. We're going to take a brief look at the history of Windows Embedded CE. We're going to talk about what's new in CE 6.0 R2, which is really one of the only slides that is very specific to Windows CE 6.0 R2. Again, it is just an update to the material, to Windows Embedded CE, so it's not like it's a new version of Windows CE or anything like that. It's just really it is a new version, but it's really just an update. Okay, and then finally we'll do a review like we do in every module. Okay, so characteristics of Windows Embedded CE. So here we're going to talk about things like the fact that Windows Embedded CE is a 32-bit scalable componentized real-time operating system. We're going to talk about all the features that Windows Embedded CE has, talk about the variety of processor architectures that are supported, a familiar and rich tool chain, talk about source access, talk about the wide support ecosystem that's around Windows Embedded CE, and we'll talk about value. These are all topics that are important from an overview standpoint for your students to choose the Windows Embedded CE operating system. Now, because I'm so used to teaching this to real students, sometimes you're probably going to hear me doing things like I just did, where I almost get in the mode where I'm teaching it to real students, to students rather than trainers. So I'll try not to do that so that I don't take up too much time. But anyway, let's move on to the first topic, the 32-bit scalable componentized real-time operating system. And here you want to talk about things that have to do with real-time operating system and basics of the operating system. Things like it provides preemptive multitasking, it uses a virtual protected memory model, multiple processes that are all portable executable format, it supports multiple threads, really an unlimited number of threads limited only by resources, 256 different priority levels, and the fact that it's based on Win32. Now, one of the things that you'll notice we don't do in the class is we don't talk about deltas between other operating systems. We really leave that up to you as an instructor to point out any deltas, and I say that with this slide for things like, back when there used to be 8 priorities in Windows CE. It's really going to be up to you to pick which topics you want to talk about from a delta standpoint, but the class is really designed for students that are fairly new to Windows CE, so they don't really necessarily want to know what the deltas are, although some of them may ask those questions. The course isn't designed to be a delta kind of class. Okay? So moving on to the next slide. This slide, hundreds of features. What we did with this slide is, rather than try to show everything that's available in Windows Embedded CE, we really just made a landing slide that you could use to now show your students some of the features that are in Windows Embedded CE. And I think that a good way to do that would be to go to the link that you see here on this slide and really just kind of scroll through that page and show your students the components that are available in the core and professional versions of Windows Embedded CE. What we listed here is we listed the primary topics that are on that page. But if you go to that page and you scroll through it, I think that your students can get a really good feel for the richness of each version of Windows Embedded CE, meaning professional and core. Okay, so rather than embed all that information into multiple slides, the idea is that it's more of an interactive experience with you as the instructor and your students. Again, more value. Students see more value in you providing things that are outside of the framework of the presentation. In other words, they can't just read it. Okay, so moving on to the next slide. A variety of processor architectures supported. So here you want to talk about each one of the processors that are supported. You might get some questions on things like PowerPC and maybe some other processor architectures, but these are the architectures that are currently supported in Windows Embedded CE 6.0 R2, same CPU architectures that were supported in 6.0. And there are sample BSPs included for each of these processors. You might want to point out that there's new BSPs that are available in CE 6.0 R2, although on the what's new in R2 slide, that one slide does point out that that there are some new BSPs. Okay, next slide. Familiar and rich toolchain. One of the characteristics of Windows Embedded CE is the fact that there is this rich toolchain that your students and therefore developers can use to build the embedded operating system and to test the embedded operating system. That would include the Windows Embedded CE plugin for Visual Studio, the emulator, remote tools for performance tuning, debugging, and information management. Again, you'll tell your students that you're going to talk about all these topics throughout the week, but right now you're really still in an introductory phase, and you're trying to give your students a feel for or set them up for the things that they're going to use during this week. Okay. Next slide. And again, I'll start going through these slides a little bit faster after I get through a few of them to show you the flow and those kinds of things. And then at that point, what I'll do is I'll try to go through slides that are very similar to previous slides fairly quickly, and then I will try to go through slides. I'll try to make notes or to give you information on anything that might be new or look a little bit different, that kind of thing. Okay, so the next topic for characteristics was source access, and here you want to talk about the different ways that your students might get access to Windows Embedded CE source code, that would include source code from Microsoft as well as source code from community source projects. A couple of them are listed here, and even more, I believe, are listed in the notes section at the bottom. If you see down here, scrolling down a little bit. You can see in the instructor notes we list a number of community source projects. Now, if you go to this link here, you'll see that you'll see a list of links to a number of these projects as well. But there's things like OpenSSH, MPEG-2, DMUX, Wi-Fi driver, Fidget, Bluetooth driver, and so forth and so on. You can use that information to finish this bullet here out about USB and webcam. You can just simply say, well, there's USB webcam, and there's also things like layered services providers. There's a BSP, a thing called Gumstix BSP, as well as these other things that are listed here. Again, more information is available for these projects at the link that you see here. Okay. That's source access. Next topic is wide support and ecosystem. So here you want to talk about really what's available to support the developers and therefore your students when they're building and developing with Windows Embedded CE. Of course, there's MSDN, which not only duplicates the information that's available in help, but it also adds a lot of other content. There's many blogs that are available on Windows for Windows Embedded CE, and you might want to point out any other resources that are available as well, conferences, things like that. Now, in the appendix, we actually have a list of a link to a page that actually takes your students to a good landing page for getting more information about these different resources. Okay. Next slide is about value. Now, obviously, you're not trying to sell Windows CE on this slide, but one of the important characteristics for your students to determine whether CE is the right fit or not for their device is, of course, going to be value. And that value is really closely linked to the components that you reviewed when you went to the link on the Professional versus Core and kind of went through the different components that are available in Windows CE. Obviously, the more of those components that they're using in any one category, the more value Windows Embedded CE is bringing to the table for that customer. So So you can do things like compare value of Windows CE with other operating systems here and that kind of thing, but I think I would only, I would just caution, make sure you're not selling Windows CE to to your class of engineers. No need to do that here. Okay, so then we move on to the next topic under operating system overview, and that topic is really history of Windows Embedded CE. Now there's going to be some slides where you actually have the first slide pop up on top of the slide, as you have here, where we actually have the timeline pop up on top of this slide for the first slide, but there really is no second slide under this topic, so we're going to move right into what's new in CE 6.0 R2. Right after we finish with this slide. Okay, but here we provide basic information for Windows CE. You want to show that the operating system has been around for 10 years. You want to kind of give them a basic idea of the of when things have taken place. And maybe answer any questions that they might have. I would say one of the common questions that's asked here is about Windows Mobile and how Windows Mobile fits into the picture. If you're interested in getting a more detailed timeline, Wikipedia actually has a really good timeline for Windows CE that you can find at this link here that's down in the instructor notes. So check that out if you don't know that information already, or if you just want to provide a good graphic, then maybe that would be something you could do. Okay, so obviously the latest release here is 6.0 R2, which was released in November, as you see here. Okay, so then we move into the next topic, and when you move into the next topic, you're going to go back to that main screen that shows the topics under operating system features. The item "What's new in CE 6.0 R2?" question mark will be in black. Everything else will be in gray, and then in about 2 seconds, you'll see this window pop up on top that lists the new features that are available in Windows CE 6.0 R2. Now, the idea of this class is not to talk in detail about any of these features that are in R2, because these features are really more detailed than your target audience. Your target audience is general Windows CE building and development, whereas these topics are very specific, things like RDP 6.0, updates for Internet Explorer, new sample board support packages, web services on devices API, smart card reader class drivers, the things that you see listed here. So you can determine, obviously, how much detail you go into in each one of these topics with your class, depending on whether there's any questions about a specific topic, or maybe your class is all from one company and they're all very interested in web services on devices API. While this class isn't targeted at that, you can choose to go into that in more detail. What I recommend to everybody, and I'll make this point more than once in this presentation, is to check out the information that's available in the help system, in the release notes, and those kinds of things. The CE 6.0 R2 install actually installs an additional release notes document, HTML file, on your machine. So have your students take a look at that file and get more information about any one of these topics. For example, voice over IP phone services, maybe they'll check that document out and find out that, wow, now there's actually support for video over IP as well. So anyway, check out the release notes, make a point to your students to look at the information that's available for them and understand where to go to find different pieces of information. Okay. So with that said, let's move on to the last slide of operating system features, which is your review slide. At this point, you just want to simply review operating system features. You want to point out that things have been very overviewish up to this point. A lot of times I find that in a class, things go a lot slower than they did here. Obviously, you're going to have a lot of questions and that kind of thing. But you also may get off topic and talk about things that are of interest to your students based on any feedback you got when they were doing their introductions and that kind of thing. I always find it's a good idea to understand what processors your students are interested in. In other words, if everybody's ARM, then you might target your your lectures and information that you're giving more towards ARM, or if everybody's if everybody is very new and only using emulator, then you might not go that far. Those kinds of things. Anyway, okay, so let's move on to the next section. I'm not going to take a break here. The next section is tools for platform development, and again, here you see the hidden slide. So this slide would actually be the slide you wouldn't see during a real presentation, but the slide that would be the title page for this module in the student manual. Okay, so the first slide that you would see would be, as I said before, a course outline slide that shows us where we're at in our progress for going through this entire course. The course is really designed to be a 4.5-day maximum course. You actually could finish this course in 4 days, but it's really kind of targeted to about 4.5 days. And really what that means is it's about 2 modules per day. But you will, I'm sure that you're going to find, as I have in doing the train the trainer sessions in person, that that the middle of the course seems to take longer than the beginning and the end. And that's because the beginning is very overviewish in nature, and the end is kind of wrapping up things. So the topic of application development is pretty short. And the topic of testing is pretty short, very complete, but pretty short because it's so streamlined. Not a lot of if this or if that in regards to testing and verification and that kind of thing. Although, depending on your audience, you may find that there are more questions in that topic. But just typical experience tells me that the middle has been more time-consuming than the beginning and end. A lot of times when I'm teaching the class, and even the 6.0 class that precedes this, I found that sometimes during the middle I feel like maybe I'm getting a little bit behind, but then you kind of get over a hump on Wednesday or Thursday, and you realize that, oh no, I wasn't behind at all. So probably be a good idea to rehearse a time, or definitely get pretty familiar with the material. And I would say that if you're halfway through by Thursday morning, you're probably doing pretty good. Okay, assuming that you started on a Monday and you're ending on a Thursday evening or a Friday. So you wouldn't want to be halfway through if you're ending on a Thursday. Maybe halfway through Wednesday afternoon, something like that. Okay. So the next slide is the topics that we're going to talk about in the Tools for Platform Development section. They would include things like the installation of the tools, the terminology, a look at the IDE, and you're also going to mention to your students that this is the first module where we're actually going to start doing some labs. And we're going to do 3 labs in this module. We're going to build our first OS. We're going to develop and test an application sub-project. And we're going to use many of the remote tools. So the topics that you see listed here are the topics you're going to talk about during this section. So let's move on to the first slide here. And the first slide talks about installation. This is a slide that can actually take a lot of time, just because I think that your experience tells you, like it does me, that this is an area where people tend to have some problems, or at least some questions, and most of those come around things like operating system they're installing on, or installing multiple versions and that kind of thing. My recommendation is that if you can install the tools separately on a machine, that's a good way to go. CE 6.0 R2 can run on Vista or XP. It can even run on Windows 2000. But I would recommend installing things in the order that's laid out in the release notes, which is simply Visual Studio 2005 first, Windows Embedded CE 6.0 second, Visual Studio 2005 SP1. Then you're going to install the SP1 update for Vista if you're on Vista. You're going to install CE 6.0 SP1, and then you're going to install the R2 on top of that. The R2 release actually contains all the QFEs through the end of August 2007. So there's no need to install any QFEs through the end of August 2007. If you have installed those, shouldn't be a problem, but there's no reason that you need to do that. Now what that does mean is that any new QFEs you'll want to install, any QFEs from September of 2007 forward. So one common question is, can I install Windows CE on the same machine? Well, short answer is there is no short answer. You can install 5.0 on the same machine if the machine is an XP machine. You cannot install 5.0 if it's a Vista machine. Now, that's not a hard comment, that's just a pretty strong comment. You will have problems if you install 5.0 on Vista, and you may or may not have problems installing 5.0 and 6.0 on the same machine. If you do install 5.0 and 6.0 on the same machine, on the same XP machine, you're going to want to make sure that you install 5.0 before you install 6.0. And if you do any uninstallations, you're going to go back and you're going to want to go back and fix anything that you left that you didn't uninstall. It's an area where a number of people have had problems and that kind of thing. I did put a link in the instructor notes here so that you could get more information. I think it was on a blog where there was quite a bit of information about 5.0 and 6.0 coexisting on the same machine. And then you may or may not get questions about whether XP or Vista is preferred. You know, I don't know that I have much of a preference either way. The tools seem to work fairly well on both XP and Vista. I don't know that I've experienced any more problems on one or the other. The one thing that you will have to take note of on Windows Vista is user account control. So assuming that your students are using that feature in Vista, it is on by default, then you're going to want to make sure that you run Visual Studio and also the Windows CE Test Kit as administrator. Okay. Other than that, I can't say that there's been any advantage or disadvantage of using one over the other. I haven't done any exhaustive side-by-side testing to see about speed or anything like that, but I think that they're probably very comparable. Okay, so then let's move on to the next slide. The next slide talks about terminology. And really the idea here is we got two slides that talk about terminology. We're kind of introducing some of the terms that you're going to use throughout this week. There are definitely a lot more terms that you'll come up with throughout the week. You probably want to make sure you let your students know that if there's any term that you use that they don't understand, or any acronym that you use that they don't understand, please ask the question. Okay, so these terms are not any new terms to CE 6.0 R2, so I won't go over them in any detail here, but there's a number of terms. What you will notice is that this table has a new format from tables that we've used in previous classes, and this format is used very consistently. One of the things that you know in regards to the previous classes, if you've taught the previous classes, is that the sometimes the tables are in different formats and things like that. Well, here we've definitely tried to keep things very consistent throughout the flow of the entire class from a standpoint of colors and formatting and that kind of thing. And so you see here the format that we use for tables throughout this entire class. Okay. Next slide is a look at the IDE. Now you notice here, if you're looking over to the left-hand side here where my mouse is at, that this slide is followed by a slide that brings in our lab. So there's really not any information or any further slide presentation when we look at the IDE. The reason for that here is that this is a really good time for you as an instructor to add value and add the interactive aspect of the class by bringing up Visual Studio on your machine and pointing out various things about the IDE as you see fit. So you can point out where all the menus are. You can point out how the menu, what falls under each menu. You can point out how to, if you close the start page, how to bring it back up. You can point out where the properties are located at and how the properties is context sensitive depending on what you're viewing the properties of. You can point out the output window and how the output window is used. You can obviously just point out many aspects of the IDE. Also, probably letting students know that this IDE, because you are using Visual Studio, is not an IDE that's designed very specifically for Platform Builder, and therefore you're going to have some features of the IDE that are not really relevant to Platform Builder. So you can point those things out as well. Now, one thing you want to do is, because you're going to understand all the labs ahead of time, you know what your students are going to do in the class, you probably don't want to spend too much time pointing out things that are covered in labs and that kind of thing. So, but use your judgment and add value as you see fit. A good place to do a demo of just the IDE and the different components within the IDE. Maybe the toolbar buttons and things like that as well. Okay, so at that point you're going to move into a lab. Now there's not a separate lab slide for each lab. Instead, what we've done to reduce the number of slides again and to give just as much information is whenever we go into a lab, that's the next topic that you talk about within a module. We simply, instead of popping up the first slide as we would in a discussion topic, we pop up a lab goals little window on top of the slide, and we list all lab goals. And then you notice that we put a link to the video for that lab. Now, I'm not going to play all the videos in this presentation for you, but I am going to go ahead and play one video for you, just so you can see, you can get a feel for how the videos work and that kind of thing. But I'll do it just very quickly here, just to give you an idea, and then we'll pick back up and carry on. But at this point, you might choose to leave this slide up on the screen while your students are doing the lab. You may choose to blank your screen at this point, whatever whatever you choose to do. But this is the slide for the lab, for the point where your students are going through the lab. It's also a good slide that after the lab's over to be on this slide and to maybe review the lab goals with your students, make sure that they really understood what they did. A lot of times people get caught up into doing labs step by step and really maybe not necessarily understanding what they did, but more just kind of following instructions. So talk to your students about the labs, maybe ask questions, those kinds of things. Again, whatever whatever works for you. Another thing that I find important to stress before you're going into your first lab is to tell the students not to be afraid to play with the different things, even if the steps are telling them to do one thing. Feel free to explore and that kind of thing. If your classroom is set up like I think most instructors set their classrooms up, the systems are just imaged anyway, so it's not like they're really going to hurt anything by playing around. So I always challenge my students to play around, try to come up with some questions for me, those kinds of things, and in doing so, they'll learn more, and maybe we'll learn something as well. Seems like I always do. Okay, so let's go ahead and I'm going to go ahead and play a video now. And I've already got Windows Media Player centered within my 1024 by 768 window. Now, if you are doing a I'll bring up Windows Media Player here. If you're doing a multiple display presentation like I normally do, what you're going to want is you're going to want Windows Media Player to launch on your same display that you're running your presentation on. So you might want to work with that a little bit to make sure you've got that smooth for your class. But you can always open Windows Media Player, and if it goes to the wrong display, you can always drag it over to the right display. But again, the video is designed to run 1024 by 768. I'm going to play it at a lower resolution here because I'm only sharing a 1024 by 768 window with you, and I'm going to leave Windows Media Player running just to kind of give you an idea. And since we're not really reviewing this lab in any detail, it'll be fine for the purposes of this train-the-trainer display here. Okay, so let me go to my videos and go ahead and launch that lab. I'll launch Lab 2-1, but as you can see, when I launch Lab 2-1, it's an AVI file. All the labs are recorded as AVI files, and they're simply step-by-step instructions for walking through each lab. So the first lab, as you know, you open Visual Studio. You then are going to clone a BSP, and you're going to clone the emulator BSP. So you're going to see that step by step, that's exactly what this video is doing. Basically, what we've done is we've walked through every lab, and we have stepped through each lab step by step. The labs are recorded in real time. We tried not to go very fast so that you'd have time to talk without doing too many pauses. I do find it very handy to use a device like an R mouse or something like that so that you can use it to control video as well as your presentation for the purposes of controlling things like media player and that kind of thing. If you have if you have questions about that or anything about the presentation today, for that matter, you can feel free to email me, and I'll provide my email address at the end of this presentation, but I think it's also probably in the presentation as well. Okay, so anyway, you can see it's taking this lab step by step. Okay, well that's enough. You guys know how the labs work. You've walked through the labs before, so I'll go ahead and close Media Player here, and we'll go back to our presentation for this training session. I'm just going to minimize it here. Let me minimize it to get it out on my share, and then let me get rid of this window. Okay, so back in our PowerPoint presentation. So your students are finished with their lab. Maybe you've shown the video, maybe you haven't. Again, it's just one of those things that is there for you to use as you see fit. You might want to review the lab goals at this point and then move on to the next section. And the next section here, of course, is going to be the next topic, and that is Intro to the Build Process. This Intro to the Build Process is a very quick topic. You're going to get into the build process in a lot more detail when we get to that point in the class. But for right now, what you want is you want to give them a basic understanding. They just did a lab where they made a build and they downloaded an OS to the target. Now you're going to want to give them an idea of what happened during that build process. Now, the choice was made to describe the build process as 4 steps for the purposes of this class. You can point out the different ways that the build process is described, from a 3-step, a 4-step, or a 5-step process. But for this class, we chose to use the 4-step build process as the number of steps. Pointing out that the sysgen and post-sysgen build step a lot of times are thought of as separate build steps. And then also, a lot of times, the pre-sysgen build step is left out because it is a build step that you very often do not want to do. You definitely want to stress that during the class as well. So here, you want to really talk about things from a basic standpoint. You want to talk about the fact that based on the OS design, the files were sysgened. You want to talk about that process, maybe make a comparison to an SDK from a standpoint of the sysgen process in a way builds an SDK for building the other components of the OS. Then you want to talk about how it built the BSP. You want to talk about how it moved all the files to a single directory called a flat release directory. And then you want to talk about how it took the information from some basic configuration files and packed all this together into an image that and show the mk.bin that was created, and in turn, of course, showing the flat release directory as well. But again, this is a very introductory process, which talks about the IDE and command line builds. You describe this as the unified build method, and you could talk about how the IDE they'll even do labs with both of these. They've already done one lab using the IDE. Okay, then the next thing is to move on to the next lab. We do want the students to spend a good amount of time in the labs. Another reason to reduce the number of slides is there was a lot of feedback that the initial material was very tight for a 4.5-day class. And so by reducing the number of slides, you have a lot more flexibility to, as an instructor, to adjust your timing. And so here we move into Lab 2-2, which is to develop and test an application sub-project. Same thing applies to this slide as this lab as the previous lab. You have a video that you can show, review the lab goals before and after if you choose. Okay, well, let's move on to the next topic. The next topic is testing and debugging the OS design. We're going to talk about both of these ideas in more detail later when we talk about debug zones and that kind of thing, and when we also talk about testing using the Windows CE test kit. But in this section, we just want to introduce the students to the different windows that are available in Visual Studio. We want to talk about the remote tools. We want to talk about how to launch a program that they may use for testing or debugging, or for whatever purposes. And then we just point out in this little pop-up here that the CETK is something that we'll look at later in the course, and that's actually in module number 10. Okay. So the first thing is debug Windows in Visual Studio. And here, what I'm really doing is I'm giving you a screenshot of the debug Windows menu item so that you can then have a bulleted list of topic points, which would include things like breakpoints, watch windows, call stacks, threads, modules, processes, memory, and that kind of thing. So anyway, you probably want to go through each one of these and talk to your students about it. One of the things that you can point out is that this is very typical of embedded operating system type windows. So if they're used to other embedded operating system development, then things like viewing registers and viewing disassembly and setting breakpoints and viewing call stacks and viewing threads and those kinds of things are very typical. All of these tools are available within Visual Studio, and you simply want to just point that out. Also, can point out that almost everything that they see here, they'll use at one time or another during labs. If you wanted to, you could actually go to your desktop and actually do a live demo here showing the different debug windows in Visual Studio and maybe asking any questions, but completely optional. Okay. Then we have the remote tools. And what I do again here is I provide a graphic that kind of gives you some bullets, but because the graphic is a little bit small, we also highlight them here with real bullets. And you have things like File Viewer, Heap Walker, Zoom, Remote Zoom Tool, Registry Editor, System Information, all the remote tools. No new tools for R2, so these tools are the same tools that have always existed. You can talk about each tool in whatever level of detail you want to, but again, you want to tell your students that they're going to use most of these tools during the class. Maybe it'd be a good idea to talk about the tools that they don't use during the class, which would include things like Zoom, SPY, and Call Profiler. The one thing about Call Profiler to talk about is the fact that they actually have to do more work in order to use the Call Profiler tool. But all the other tools they'll actually use during labs this week, with the exception of Zoom and SPY. That assumes that you have the students do each lab. Again, the course is designed so that the labs could easily be replaced. If you have a class that you know is going to have a lot of interest in a certain area and there's not a lab in that area, then you may choose to replace a lab or two with your own labs that are more applicable. Okay, next slide is a slide on how to run programs. My PowerPoint seems like it's running a little bit slow here, probably because I'm running a live meeting at the same time. But the next topic is how to launch a program. So you want to explain the different ways to launch a program, and we just show 3 graphics of different methods that your students will use this week to run programs, which would include things like the target control window, the run programs dialog, and the command line from the actual device itself. So talk about these in any level of detail that you wish. One of the things I like to point out at this point, because this is the first time we're talking about the target control window, is to have your students type in a question mark and look at all the information and commands that are available through the target control window. You probably also want to point out that many people call that the Windows CE command prompt. It's not really a command window, though. You also, and at the same time, some people call it Windows CE prompt. So Anyway, talk about that in whatever level of detail you choose. Do a demo if you want to. But again, I think probably my main added value here is to make sure the students type in a question mark and look at the different commands that are available to them in that target control window. Okay. So then we move on to Lab 2-3, which is using the remote tools. This lab is the same lab that we had in the past. One thing you will notice about the labs in this class is that some of the labs have actually been combined, but none of the labs have actually been removed. And the reason for combining the labs was if there really wasn't enough information to provide between labs, or if the labs were back-to-back, then the choice was made to combine the labs to make the class flow a little bit better. So you may see that some of the labs have actually been combined. I don't think there were many of those, but there might have been 3 different labs that were actually combined into another lab. Okay. So using the remote tools. Then the next topic is the Windows Embedded CE directory structure. Now, in this section, you're really going to start diving into some detail. This is definitely a section where I like to go off and use my Windows Explorer to show students these different directories and what exists in each directory, and really start to take them into that process that you want to make sure you portray to them, which is look around for the things that are available within these tools, because there are some things that are undocumented, and you can really learn a lot by just browsing around in the directories, but not only in the directories, also when we talk about topics like the registry, the registry and things like that. Just looking through a Windows CE registry a lot of times can give you some valuable information. So take them on a tour of these directories, explain each directory. We have a slide on each one of these coming up. But in addition to that, you also want to talk about environment variables. You want to talk about how their environment variables are extensively used for path information. For the tools, and you probably also want to open a build window and have them run the set command, or you run the set command and demonstrate to them all the environment variables that are available or that are seen in the command prompt. You want to point out that those environment variables aren't set globally for their development system. Instead, they're set by opening a command prompt specifically for Windows Embedded CE, and you'll talk more about that later as well. Okay, so let's just go through these slides here. You have a slide on environment variables. Here we talked about the set command and some of the environment variables, but you notice the last bullet there is that there are many, many more. So doing that demo is a good idea. Then we talked about the OS Designs folder. We talk about the platform folder. Nothing new here. There are some new BSPs in the platform folder. You actually notice that on this system, in the graphic, you see there's a voice over IP BSP folder there for PX8270. That's actually one of the new ones. And then you see the one that's highlighted there in the graphic, Training BSP, which is the one that your students cloned. These screenshots were actually taken from a system that was actually used to run the labs. Okay. So that's the platform directory. Then you want to talk about the public directory. I always like to take my students into public common open drivers because there's so many examples of code there and so many examples of drivers that it helps many of them out when they're doing their own development or when they have questions. Another one of those points that I like to make is that if you're doing development and you have a question, well, yeah, you might find the answer in the help system, but sometimes the answer in the help system is just not good enough for you. Maybe it's not complete enough and you want to know more about it. Well, use that source code that's available to you through these different avenues, including the public common open drivers folder, to find an example of how the API is being used, and maybe that really gets you a lot of information that you're looking for. Okay, so that's the public folder. Then we have a slide on the SDK folder. Typically with the SDK and the others folder, I like to tell the students that this is a folder that you definitely want to take your time and look through, but there's really not a lot here that you're going to come back to. But every once in a while, even myself, with a good number of years of Windows Embedded CE experience, I like to look in these folders and remind myself of what's there. Anyway, pass that information along, and hopefully it benefits them at some time. Then we have the Others folder, and finally we have the Private folder. You probably want to point out on the Private folder that it is an optional installation step. Okay? I would say that this is these directory structure slides within module number 2 are slides that you're going to want to spend quite a bit of time on to make sure that your students really understand the directory structure. I think that you want to point out that that understanding the directory structure in Windows Embedded CE from a building standpoint and from a information standpoint is just a very strong thing. Having knowledge of this directory structure definitely helps you to be a better Windows Embedded developer. Okay. Then we have a slide on the Visual Studio directories, and nothing's changed here. But the different Visual Studio directories that are associated with Platform Builder or Windows Embedded CE in one way or another. And then finally, we end module number 2, as we do all modules, with a review slide. At this point, same as all the other modules, you'll want to maybe take notes of points that you haven't answered, questions that you haven't answered. Maybe you want to review some of the things that you've done. Maybe you want to review the labs that the students have done so far. Ask if there's any additional questions on the topics that we've talked about here. If not, then you're going to want to move into the Operating Systems Internal module. We're going to do that, but I'm going to take a quick break first, and then I'll be right back. Okay, well, now we're going to talk about operating system internals, and this is the hidden slide, the title slide for that section. So let me move to the first slide that you actually show in your presentation. So you can use this slide for each module to talk about, okay, well, we've already gone through operating system overview and tools for platform development. Now we're in operating system internals, and we're going to cover that topic. But you can also, kind of give your students a frame of reference for where you're at in the course. Now we're going to actually be starting to get into more detail and those kinds of things. Okay, so operating system internals. In this topic, we're going to look at system architecture, memory model. We're going to do 3 labs, one on using memory tools, exploring threads with kernel tracker, and a look at synchronization. Now this is one of the modules where we actually did combine. I think 2 of the labs that were combined were actually from this section. If I remember right, we had 5 labs in module number 3 before, something like that. Anyway. We're going to talk about processes and threads. We're going to talk about synchronization objects, and we're going to look at the interrupt model, and then we'll end up with a review, as we always do. Starting out here, the first topic is system architecture, and this is a 1-slide topic. You're going to use this graphic to discuss all the different aspects of the system architecture. Really, I find it easy to start at the bottom and work my way up, but you can go at it either way. First thing is probably explain what the colors mean and how a lot of times OEM and ISP are one and the same, but not necessarily. So I like to start at the hardware, then talk about the OEL and the drivers. Talk about the Microsoft components that are in the kernel, and then talk about the Win32 APIs and interfaces, and then and the other user mode applications, including the hosting process for devices and for services. Okay, Let's see, any special notes on this slide? One of the things that you remember from probably the previous version of the material was that we had multiple slides to talk about this topic. Well, here again, you only have one, so I imagine you're going to spend quite a bit of time using this graphic and kind of talking about things throughout the entire operating system. So it's a one-slide topic again. If there's anything that comes to mind for this slide, I would say that a lot of times I like to describe the OAL as a driver for the kernel. Makes it easy for people to comprehend what the OAL is. But you can tell your students that you are going to talk about some of these things in more detail later, but right now what you're really trying to do for them is give them a picture of how does this operating system really work, how is it componentized, how do the pieces interact with each other, and those kinds of things. Okay, so anyway, that's it for that slide. Let's move on to the next one, and that would be the memory model. So here you're going to talk about the virtual memory model, the user virtual memory, kernel virtual memory, and the memory system tools that you have available for you for viewing different things in memory in Windows CE. So these slides were reworked quite a bit, but the first slide is the virtual memory model slide, where you're actually going to show that basically your 4 GB address space for a Windows embedded CE device is split into 2 and 2 gig, where your lower 2 gig is your instances of user space, and your upper 2 gig is your single instance of kernel space. Then we're going to break each one of these down, starting with user space. So we describe user space here, and we show, basically the breakdown of that 2 GB of user space that sits below the 2 GB of kernel space. You could point out things here like Windows CE supports 32,000 different processes. All of those processes, with the exception of nk.exe, runs in user space, which is why we show a per process virtual memory area here. Now, while the entire 2 gig is considered instanced, one of the things I do like to point out is really only part of that is really multi-instance in a way that is separate to each and every application that's running in user space, and that's that 1 gig space. But point that out however you see fit. I did break things down here so that the different areas are pretty finely detailed here. But in the actual per process virtual memory space, rather than break it down into separate graphics, kind of just listed everything there from the bottom to the top, so that you'd be able to have a quick reference for explaining what exists in the per process virtual memory area. Other than that, I don't think there's anything new here, so we'll move on to the next slide, which is the kernel slide. Again, same kind of slide here, except this time we show the user space being multi-instance, and now we're really showing everything above. We're really breaking down everything above that user space, which is called the kernel virtual memory space. And so here, break down all of that space, and you can provide any details in any level that you'd like of what's contained within each area and that kind of thing. So I do think this is a good slide to explain how the static map cached and uncached regions map to your physical memory. So I think that's probably one good thing to do on this slide. I think it's really good to do that on a whiteboard where you're actually showing physical memory and how it maps into the cached address space, and then how an exact duplicate of that is mapped into the uncached access space, allowing both cached and uncached access depending on how the memory is being used. Okay. So not any new information there, but some new graphics. Next slide is the lead-in to the memory system tools that are available to your students. That would include things like process viewer, heap walker, kernel tracker, system information, target control commands for getting memory information, and tool help heap functions. I think that some of these are more useful for memory purposes than others, but things like the gimod command, for example, that only gives you really the base address of what's being loaded. With that said, you could talk about how the base address for applications is 64K in Windows CE, and then what I like to do is I actually like to go look at some examples, maybe launch my system and launch a remote or launch the gimod command and show where modules are located at, and then I like to go back to the slide that we had in either user mode or kernel mode and show them exactly how it maps to the addresses that they see listed in these graphics in user mode and kernel mode. And in turn, if we go back to the user mode slide, I like to show them, well, yeah, here's where every application starts or loads at, and that is the offset 64K, and you can see by this graphic that in fact is the case. So it kind of gives them a correlation of the information, and possibly makes things more clear. Okay, so let me go back to the slide we were on, which is the memory system information tools. Now, each one of these, we're going to have a new slide on that provides a little bit more information. I think maybe there's not one on the toolhelp.dll, but you can explain that in more detail. How it's a set of APIs that allows your students to build their own tools or to maybe integrate into some other application to provide some diagnostic information for the system. But we have a slide on the process viewer that you see here. I think that demoing this is always a good thing, but your students will use it, so maybe point out key aspects of the process viewer. You can move on to the heap walker slide and tell them they're going to use the heap walker in a lab, but maybe point out some things on this slide as well. These slides are just provided for you to provide any level of detail you want, from as simple as here's an example of the heap walker tool, and you'll be using this tool a little bit later in a lab, to maybe details about every one of these windows that you see here within the heap walker, the process list, the heap list, and the heap dump. Again, provide the level of detail, maybe less detail if you need to play some catch up, more detail if you don't. Okay. Next slide, kernel tracker. A lot of people ask the question, well, why do you list kernel tracker for heap, for memory-related tools? And the main reason is about heap events, the fact that you can actually track heap events within kernel tracker. So your students are going to use kernel tracker in a number of labs during the week, so they'll definitely have time to play with this tool. You don't have to go into a lot of detail with this tool. Just make sure you mention that they can track heap events. Okay, then we have the system information tool, and it has a memory component to it, or a memory viewing aspect to it. It gives them some basic memory information about the system. Then we have the GI command, which we had said gives them the the virtual memory base address. And then we have the MI commands. So you'll want to talk to them about the MI kernel, MI full command, and then we also provide a legend slide for them so that they can actually see what all these different letters mean when they do an MI dump. And so we have the legend here, and again, this is just in our standard table format. And my PowerPoint's being a little bit slow there, but we list all the different symbols that are used within the MI full command. Okay, you might want to go through each of these symbols and explain, kind of how each one works, and answer any questions about the different symbols, that kind of thing. Okay, and again, as you can see down here in the instructor notes, that if you need more information about any of this, then you can go to this link here on MSDN and get more information. Okay, so next is the lab on using the memory tools. So your students are going to go through and they'll do a lab 3-1 on using memory tools. You will notice that on each lab slide, it's very obvious you're on a lab slide, not because it only says lab, but we also use icons on the slides to kind of let you know where you're at as well. It's a very easy graphic way to know, oh, I'm on a lab slide now. And as we move to the next slide, you'll see that on the topic slides, we actually have that arrow pointing both ways icon, and kind of just shows you, okay, now I'm back up at that level. And the idea was to try to provide flow information to make it easy to know how you're doing from a progress standpoint, and to know, relatively where you're at within the deck of slides. The other thing that I think you could use that I tend to find very useful is when you present in presenter mode, where you actually have a view of the upcoming and previous slides while you're viewing the slide that's currently shown for the students. Makes things very convenient as well. Okay, so in the topic on processes and threads, we look at processes, threads, and the scheduler. So we have a slide on each of these topics, and I don't think there's any new information here. Nothing's different about R2 in this regard. The slides have been cleaned up and maybe reformatted a little bit, that kind of thing. But other than that, it's the same information that you had in the 6.0 class. If I come across something here, then I'll point it out. Otherwise, we'll kind of just thumb through these slides. But we go into details about threads and scheduling as we did before. We talk about the typical priority map and talk about priority inversion and show an example of priority inversion using Kernel Tracker. And you can talk to your students about how Kernel Tracker is a valuable tool for looking at threading issues, and one of those issues obviously would be priority inversion. This is also a good slide where a lot of times for students that don't understand priority inversion, that you can use a whiteboard and actually kind of demonstrate priority inversion graphically if you'd like. Okay, next tool is, the next slide is the processes and threads tools. And here you want to talk about toolhelp.dll for viewing process, module, and thread information. You want to talk about the processes window, which they've already looked at in the lab, the threads window, the target control window for GIProc, GIThread, GIDelta, and GIAll. You want to talk about Kernel Tracker and the remote process viewer. We don't have separate slides on all of these in this section, but all these are windows that your students have already seen at this point, or that you've demoed, or you could demo right now if you so choose. Okay. Next slide, we talk about the different process and thread-related APIs. Now, we actually have a few slides that show the process and thread-related APIs. The idea here is not necessarily that you're going to explain what every API does, but you want to give your students a feel for the depth of APIs about various topics in Windows Embedded CE. And so we're going to do this on a number of different topics, but in processes and threads, that's one area that we do provide a list of APIs with a 1-sentence, 2-sentence max overview of what that API does. So it can be used by your students as a good reference, that kind of thing. Okay, so that's process and thread-related APIs, and then here's another slide on some additional APIs for processes and threads, and one final slide for processes and threads. Okay, and then we move into a lab, and that lab is on exploring the threads with Kernel Tracker. So the topic that we just discussed was on threads, and we do a lab that kind of lets the students play with tools and look at things in more detail. Again, I would point out that it's very important for the students to explore while they're doing the labs. Okay. So next topic is synchronization objects. So we're going to talk about various synchronization objects. We'll include critical sections, mutexes, semaphores, events, and interlock functions, and point-to-point message queues. These are things that we've talked about in previous classes, so I think everybody's probably familiar with the topics. but let me scroll through here and see if there's anything new to point out. Critical sections, we show a few bullets, and we show an example of, or we show the APIs that are specifically related to critical sections. We're going to do this for each of the different synchronization topics. It definitely would be a good idea, if possible, to show a example of use of critical sections. You could definitely do that. The most important thing to point out about critical sections is that they are thinner than a mutex, and if you have a need for exclusive access within a specific process, then using critical sections can be advantageous. Okay. Then we move into mutexes, same kind of format here. We have some bullets about mutexes, things specific to a mutex, and some APIs related to a mutex as well. And then we do the same thing for semaphores. We do the same thing for events. But events are a little bit more complex, and many times, I know even myself, when I start thinking about events, it's like, okay, well, how did it work if it's an auto reset event and pulse event was used? So what we do in addition to providing this slide is we also provide a little table here, and the idea behind this table is to show a comparison of auto and manual reset events and how they're used with pulse event and set event. So I find this slide very handy for your students to use as a reference, and also a good slide to just explain how it works. So anyway, use that slide to do exactly that. Okay, then we move on to a slide which is on interlocked functions, and talk about interlocked functions a little bit. And because there's a number of interlocked function APIs, we actually move those to a separate slide, as you see here. And this slide just simply goes through each of the APIs and gives you a brief description of what those APIs do. Okay, then the next slide is on point-to-point message queues. It's our final slide on synchronization objects, and same kind of thing, a few pieces of information about point-to-point message queues, a listing of the APIs, and a description of each API. Okay. Then the next topic is to let the students do a lab on synchronization, and here this is quite a long lab, but they get to explore the different types of synchronization objects and run through a lab on doing that. The lab timing is actually presented on the front page of each lab, and that timing has been somewhat conservative, meaning if the lab took say 10 minutes for someone that's very experienced in Windows CE to do, it's very possible that we allocated a half hour for that lab. Because not only do we want the students to do the lab, and they're probably going to be slower at it than somebody who has Windows CE experience, but also we want them to take the time to explore and those kinds of things. So the timing I think is good timing for the labs. I would say, if anything, you might even want to allow a little bit more time for them to explore around, depending on how the timing in the class is going. That's lab 3-3 on a look at synchronization. Now we're going to move on to the interrupt model. But before that, I'm just going to take a really short break here, and I'll be right back. Okay, now we're going to talk about the interrupt model. So let's move to that slide. And the basic model for interrupts is the first thing to talk about here, and that is that the hardware triggers the kernel interrupt handler, which calls your ISR. The kernel interrupt handler is provided by Microsoft. The ISR is provided by the OEM. ISR returns ID. Kernel schedules the IST associated with the ID. And now you want to break that down into detail. Here's our first slide to do that. The first thing to talk about is we're really going to expand that process, or that basic process, into 16 steps. And so this interrupt sequence slide purpose is to actually review those 16 steps with a graphic that helps visualize that. But interrupts are handled the same way in R2 that they were handled in the previous versions of Windows Embedded C, so nothing new here. And then after we talk about that interrupt sequence, we're going to specifically talk about IRQs. We're going to specifically talk about sysinterrupt IDs. And we have a few slides here to talk about some specific topics. Then we talk about the ISR. And you'll notice that as we talk about a topic, it basically highlights it in the same graphic. Anytime we could use the same graphic within the materials, or anytime it made sense to, we definitely tried to do that. The thinking there being that it causes the students to see something that looks familiar, but at the same time to be introduced to a new topic, and so it's not everything new at once kind of thing. Okay, anyway, we talk about the ISR, we talk about the IST, and then, since we're on the topic of interrupts, you got to talk about shared interrupts. Shared interrupts work the same way in CE 6.0 R2 as they do in the previous versions. Nothing really new here. And we talk about installable ISRs, how installable ISRs work. We talk about the generic installable ISR from Microsoft and how it's suitable for many devices. Talk about the fact that it is registry driven, and you can actually provide more details, show example registry settings, that kind of thing. Nothing new there though. Okay, and then of course, like we've done for some other primary or fundamental topics, we show a list of related APIs. And here we show interrupt-related APIs. So different APIs that have one thing or another to do with interrupts in the system. Now, a lot of other APIs could be shown here, from things like creating an event for use with interrupt initialize, but those are topics that are at least somewhat removed from interrupts. So, and they're also discussed other places, so those kinds of things aren't included here. But you might choose to go through these different APIs and talk about when within the 16 steps that we discussed earlier, those APIs are used, and that kind of thing. Okay, so the interrupt model was actually the last section within the operating system internals topic, or module number 3. And so now we're going to move on to the next module, and that next module is operating system components. And so we will go there now. So the first slide that they'll actually see is the operating system the course outline slide that has operating system components in black. So I was actually just thinking as I was thumbing through the slides, wow, how come I hit another slide there? Well, another thing that you'll notice is that in some modules there's an additional hidden slide at the beginning. The whole idea behind that, and I'm going to scroll back up here to it, is you see this is a hidden slide for print only, and the actual page, if you look at the page in the notes view or in the student manual or instructor manual, it just simply doesn't have the slide on it, but it just simply has the comments. And the comments are, this page is intentionally left blank for odd page module alignment, meaning that we want to treat each module as a chapter, and therefore we want to start chapters on odd pages. So that was the purpose of having an extra module, an extra slide at the beginning of this module. Then we moved into the title sheet, which would be the first page of the title. And as you can see, this is on page number 109, so that would make sense. And let me get rid of that window that popped up on my computer there. Okay, so now we're going to move to the intro slide that would actually be presented for this module, which is operating system components. So here we're going to talk about some basic operating system components. Now the choice was made when Windows CE 6.0 course was put together about a year ago that these topics would be talked about. We haven't changed those topics. We stuck with the same topics so as not to make too many changes to the course. And so those are the topics that we're going to talk about. And they include the file systems, the registry, power management, and internationalization. In this section, in this module, we're going to do 2 labs, one on using the remote registry editor, and the other lab on experimenting with the power management.
Okay, so the first thing is file systems. You want to talk about the different file system drivers that are available out of the box. You want to talk about the fact that third-party file systems are supported. Support for databases is included. You want to talk about the fact that file system filters are supported on top of file systems and how file system filters can be used on multiple file systems. I actually have a slide on that. You want to talk about security features and how the file system in Windows CE is rooted at / with the RAM file system or with an optional file system mounted at the root. You want to talk about how no drive letters, no current directory are used within Windows CE. And you also want to talk about how file system drivers are managed with a thing called FSD Manager. Okay, so let's move on to the next slide. Next slide shows some FAT utility APIs. So you can talk about how these APIs can be used for any component that's actually using a FAT file system. And you can also take them to the example of code under Public Common drivers FSD. And show them the code that actually exists for the FAT utils. Then we have a slide on the RAM object store, talking about the RAM object store and what it is. None of this information has changed from the previous version of the class. The RAM object store is transaction-based, how its maximum size is 256 megabytes, maximum file size of 32 megabytes, and about 4 meg of objects. The system supports file system filters. Example, or the idea is that it looks a lot like a shim file system driver, and we list a number of examples here of things that you might use a file system filter driver for. Then we show file system architecture, and so here it actually shows a file system filter on top of a file system, on top of a partition driver, and so forth. And then we also show how FSD Manager also manages the object store. Then we show how multiple file systems and filters can be used together. Nothing new there. Registry, nothing new here. We do an overview. We talk about the types of registry, registry-related tools, and registry-related APIs. So I'm going to start going a little bit quicker now. An overview of the registry. And again, I think I'm going to start going a little bit quicker here, and what I'll do is I'll point out things that maybe are enough different that I think any special mention needs to be made. The registry, now we talk about Hive and RAM-based registry. We look at the registry tools and talk about how the registry editing capability in a graphic format is actually built into Visual Studio with 6.0. And you can also use the remote registry editor, which they've already done at this point, I think. They will in the next lab for sure. Then we talk about all the registry-related APIs. And there's 2 slides on registry-related APIs. Then we have 1 slide on registry notification APIs for change notifications. Then we do a lab with using the remote registry editor. Have a lab, or start to talk about power management. I think one of the things that I like to point out here is that power management often is a big job for in Windows embedded CE devices. Many times is one of the bigger jobs for building an operating system. I think the topic is laid out pretty much the same way it was in the previous version of the course. Talk about an overview of Power Manager. Talk about how it has application and device interfaces. Talk about how Power Manager determines when to change the system power states. It only controls drivers that are Power Manager aware. Drivers don't have to support Power Manager, and devices drivers must advertise that they support Power Manager if they want PM control, and they can do that in 1 of 2 ways, and this hasn't changed, using the ITest value in the registry or the Advertise Interface API. Okay, let's see. the PM directory, show them what exists there in any level of detail you choose. Talk about how it's an MDD PDD model. Again, nothing's changed from a Power Manager standpoint in Windows Embedded CE 6.0 R2. Okay. Here's an example of device state code. You can just use this as a good example. I do like to point out that the PM dev sample is a good example of implementation of a power management within a driver. So you might want to take them to the PM dev sample code and actually show them the code and that kind of thing. Okay. Talk about how applications can use power management as well, using request power notifications, API. Applications can request a system power state, talk about how that works, and talk about how while they may request it, doesn't mean it's absolutely going to happen. Applications can set the power state for a device using the set power requirements API. Okay, and then here's a list of all the APIs in a nice table, as we've done with other fundamental topics. Okay. Then we talk about idle power management. So nothing really new here, but that's really all about OEM idle. Show the basic power management architecture with a graphic to kind of pull all this together, and hopefully at this point things are starting to come together from a power management standpoint for the students. Talk about device power state changes, and how that works with device I/O control being the interface that the driver exposes if it's PM aware or PM controlled, and how it uses device power notify to communicate to power manager. Talk about the system power states and what they mean as implemented by default by Microsoft. And then we also talk about the device power states. And then finally, we also want to talk about how they map together. So we have a slide on that as well, how system power states map to device power states. Then we want to talk about activity timers and how Microsoft provides two default activity timers, but you can add any number of activity timers to use as you see fit. Talk about the Power Manager suspend and resume sequence. And we're going to detail each of those sequences, the suspend path and the resume path. And this is the same information that was there before. This hasn't changed in R2. Graphics have been cleaned up a little bit and tried to make it more consistent with the rest of the slides and that kind of thing. But otherwise, it's the same basic information. So we have the suspend path, and then of course after we suspend, we want to be able to resume. So we talk about resume next. All right, now we're going to let the students do a lab on experimenting with power management. After that, we are going to talk about internationalization. Got a few topics to talk about here. A pretty brief topic to talk about from a material standpoint. Also fairly brief on MSDN. But here's some slides that, depending on your audience, you can spend more or less time. We talk about the platform localization options dialog. Talk about the locale support that's built into Windows CE and how different languages have different support. Talk about different internationalization related components that are in Windows CE. Talk about the multilingual user interface component in a little bit more detail on how it's used. Nothing new there. And then we do a review of Mongo 4. So the next topic is going to be build system, and we're going to go ahead and wrap up the build system. Then I'm going to take a break for something to eat, and then I'll be back after that. But I guess let's go ahead and go through one more module, which is the build system, and then I'll take a quick break. For you, I imagine that's very quick since you're watching this recorded. Okay, so the build system, because the build system title page aligns on the odd page, there's no reason to insert a page as we saw in the previous module. Okay, so module 5, the build system. Here, directory structure, we're going to look at directory structure of the build tree, and these topics that you see listed here, won't bother going through each one of them in detail, but I will go through the slides fairly quickly. The idea behind this first topic of directory structure is just to reiterate the directory structure of Windows Embedded CE, and to make sure your students don't have any questions about what the directory structure looks like and how it's used from a build process standpoint. So it's just one slide. Then we actually talk about the build process. Now the idea here is that we're no longer just showing those 4 phases of the build or 4 steps of the build. Now we're actually going to go into some really good detail about how the build process works. This is not new information, so while the information has been reformatted and that kind of thing, it's same basic information that we had before, talking about all this phases of the build, which have existed, pretty consistently for quite a while. So we talk about the pre-sysgen phase, talk about the sysgen phase and how it acts like a filter, hence the funnel kind of idea. Then talk about the post-sysgen build phase, where it actually builds the BSP. Talk about how the post-sysgen build phase can actually have an optional sysgen step as well, how that's typically used by Microsoft, but could be used by an OEM if they so choose. Talk about the build rel phase, also known as the release copy phase. Nothing really new here, just again reformatting. Make image phase, how it's used. Then we go into the configuration files. In order to complete the topic of the build process, you really need to go through and explain how each of the files that are used in the build process work and are put together and that kind of thing. So we talk about these 4 configuration file types, the primary 4 configuration files that are used within, or file types that are used within Windows Embedded CE. Talk about how they're put together and where they come from and that kind of thing. We have a slide on each one of them, actually multiple slides on some of them, to talk about the different aspects of the files. So for example, bib files, we want to talk about the memory section, and you notice that we have config.bib listed here, since typically config.bib is where you're going to find that memory section. So we talk about the bib files. I think that this is a good point where the instructor can actually go open up a bib file, for example, for the training BSP. I would open up the config.bib and I would show the students the memory section within that config.bib, which you have here in a graphic. If you show it to them in directory structure, I think it just helps that point sink in. Okay, so the memory section of config.bib, then we talk about the config section of config.bib. While you have that open, talk to your students about how the config section is used, and talk about how it's, the miscellaneous settings that are shown there. Maybe even talk about what some of the settings do, but also talk about the fact that there's many miscellaneous settings that you can set in the config section, and that they can look at those in the help system if they so choose. Another thing that I tend to point out on these files is that it's not something that you necessarily need to memorize, because it is something that as a developer, maybe you set it up one time for a specific BSP and you're done and you leave it alone. So it's not something that you're really spending a lot of time with. Okay? And many times it's also a cut and paste type operation where you're taking an existing BSP and you're modifying it for your hardware, maybe making a few changes here or there, that kind of thing. So then we talk about the module section of the bib file. Then we talk about the file section of the bib file, and again, you can show them examples of all of these things from their training BSP or from their OS design and their training OS design as well. Then we talk about the reg files, and we talk about how those reg files can be edited with the built-in editor, as you see here. Okay, then we talk about DAT files and how DAT files work. Talk about the basic structure of a DAT file. You can use the graphic as an example. Talk about database files as well, and talk about the format of the database file a little bit. Show the example of the graphic that's shown here. Okay, and then we provide this chart, same chart that we used to have, just reformatted to fit the new style and that kind of thing, and talk about the fact that these are general guidelines, but really experience is what's going to really help make sure that the right build steps are being done at the right time, and you're not, taking more build steps than necessary. Okay. Talk about the different types of builds and how there's a debug build, a release build, and a ship build. Okay, nothing new there. Talk about the ways that you can speed up the build process, both from a hardware standpoint and from a development process standpoint. I think that pointing out that the steps that they're taking in these labs to build an OS and release and build a sub-project and debug would be a good example of that. Okay. Then we talk about the build tool. So we're going to talk about build.exe and how DIRs and sources is used, how sources common is used, and how makefile.def is used. Nothing really new here for CE 6.0 R2. So I'll go through these slides pretty quickly. Show an example of where to find a DIRs file and show what a DIRs file looks like. Again, I thought, as an instructor, I always find it advantageous to show students the real directory and open a real Windows Explorer window and open up a DIRs file and show them that DIRs file and show them that DIRs file contains other directories. Go inside of those directories and show them what's inside that directory. Really kind of give them the demo, if you will, instead of just a graphic. Okay. Talk about the sources file and how sources files are used and how sources files use a number of different macros. This table explains some of those macros, but you'll want to tell them to look in the help system if they want to know what all the different macros do. Maybe open a sources file and show it to them. I think the OAL is always a good one to do. Then we talk about source libs versus target libs, and a request was made to add this slide, and so talk about how that works and talk about why it actually works that way, and so this slide was designed to do that. Okay. Let's see, sources common, talk about how sources common works. And this topic was talked about in the previous course, but basically, instead of walking down the tree, build.exe is going to walk up the tree of DIRs files and find a sources common file with common settings. Then we have makefile.def. And you can talk about this briefly, or you could even talk about it in great detail if you wanted to. You could open up the makefile.def from Public Common Oak MISC and show your students the complexity of makefile.def. Maybe that'll show them the advantage of using sources files. But again, we definitely want to mention it since it is the master makefile for almost every component that's built within Windows Embedded CE. Then we're going to let them do a lab on building static and dynamic libraries, lab 5-1. Then we're going to talk about the command line, same topics that we talked about before. WinCE.bat, environment variables, setting up command line builds, build demo.bat, and mapping IDE commands to command line. Also talk about automated builds. So I'll go through these fairly quickly and point out anything that warrants some extra information. We've got WinCE.bat here, talk about environment variables, talk about setting up a command line build. We actually do provide a sample of using PBXML utils at the bottom there. Then we have, the idea with this graphic was to make it obvious how the command line is used to trigger various steps of the build process. And so, hopefully this graphic does that well. Then we have a graphic that shows the menuing system of Visual Studio and how it relates to the commands, the command line commands that are used to actually execute the build. So the numbers correspond to the numbers on the left correspond to the numbers on the right. And then, of course, we also have the global build settings and targeted build settings. We want to talk about how those work. Then we have the targeted or the solution explorer build commands and how they map to actual command line commands as well. So again, the numbers on the right and the numbers on the left correspond to each other. Okay, then we have a slide on automated builds and the basics of automated builds, what they should save and how to develop an automated build succeeds or fails, that kind of thing. Don't talk about any source control systems and those kinds of things, but the topic does fairly come up around that slide. So you can talk about that in whatever level you're comfortable with. Then we talk about building from the command line, or we actually do a lab on building from the command line. We just talked about building from the command line. Now we're going to let the students do a lab on it. Then we're going to talk about troubleshooting the build, look at build output windows. We're going to look at log files, and we're also going to talk about the different errors that they might see. So these are some basic screens to let you talk in more detail about the build output window, what it looks like when they're starting a build, what it looks like when they are in the sysgen phase, what it looks like when they are in the build of the BSP phase, what it looks like when they're in the build rel phase, and then finally the make image phase. And then, of course, when the make image phase is complete, you want to know if you got a successful build, and this example here actually shows a successful build with an nk.bin. It's about 19 meg. Okay. Then you want to talk about the three different types of log files that are created, build.log, build.warn, and build.error. You want to definitely talk about how build.warn and build.error are only created if there are warnings or if there are errors correspondingly. Okay, talk about the different errors that might occur, same information as before. And then you're going to let them finish up this module with a lab on troubleshooting link errors. After they do this lab, then you're going to do the final review of this module. After that, we are going to, we have a slide here that takes care of the odd page alignment for the next module. And the next topic that we're going to talk about is going to be the board support package. So I'm going to leave us off here at the introduction slide for the board support package for Module 6. And I'm going to take a break, and then I'll be right back. Okay, now we're going to look at the board support package module. So let's move to the first slide here. Talk about the different topics we cover in the board support package. We do an overview of BSPs. We talk about platform common code, BSP components, the different components of the BSP. The students are going to have a chance to do 2 labs in this section, a lab on registry initialization, and also a lab on adding an IOCTL to the OAL's OEM IO control routine. And then we also have a section on creating a new BSP. So this topic is very similar in content to the previous class. First, we talk about what is a BSP and talk about how it's a directory that basically contains all the hardware support code, hardware-specific code, bootloaders, OALs, drivers, and configuration files. Talk about how typically there's a one-to-one mapping between the hardware and the BSP platform. And we talk about the fact that it's required to build an OS. So where are the BSPs? Same topic that we had in the previous class. Talk about where to get those BSPs and how Microsoft supplies them, how you may get them from third parties, including OEMs and other device makers. And maybe you're going to build your own. Almost always you're going to clone your own at a minimum, because even if you're using a Microsoft BSP, you definitely want to clone. So one of the things I like to stress here is that it is important to clone a BSP before you use it, so that way you maintain the original in its original state. Okay, then we have the platform common code to talk about, and so you want to talk about all the benefits of using platform common code from a standpoint of production quality and promoting reuse uniformity and a modular approach. Talk about how it's not mandatory, but can be advantageous. Can be very advantageous from a time standpoint, saving lots of time in development of the code. At this point, a lot of times what I'll do is I'll actually go through the directory using Windows Explorer and show many of the different aspects that we're going to view here in slides. And so you can pick any time during this topic to go do that. It just gives the users, again, a more hands-on experience or a more better demonstration than what you can do with a single graphic on a slide. Okay, so then in BSP components, same thing applies. You could take them on a tour of their training BSP and show them all the code within your training BSP and how it's organized. But here we talk about bootloader, OAL, and drivers and files. Drivers we really talk about in the next module. Okay, so talk about the bootloader. No new information here. This is the same information, kind of reformatted to be consistent with the formatting of this PowerPoint deck. Yeah, nothing really new in regards to the bootloader. Nothing new from a CER2 standpoint for the bootloader as well. Okay, so we'll talk about BL Common and how BL Common is used and how it can save you a lot of time. It's a lot. You could actually point out that BL Common is just one aspect of creating production quality, a production quality BSP, using code that has a lot more runtime on it, promotes modular approach, those kinds of things. Okay. So talk about how BL Common is used, and again we use the colors here to show who's developing what and that kind of thing. So okay, the OAL, next topic, talk about the OAL. There's really nothing new in this section as well, same information that was there before. The important thing to point out to students that are familiar with previous versions of Windows Embedded or Windows CE is that the trust model is a lot different in 6.0, but between 6.0 and R2, nothing's changed. Okay. Talk about how the OAL is built. A lot of times what I'll do is I'll go to that directory structure for OAL.lib and OAL.exe and actually show how OAL.exe is actually put together. And then I'll actually even go a step further than that and actually show how it's renamed in K.exe in the build process. So it gives them a good build of the BSP to build rel to make image concept by just doing a little demo there. Okay. Then we have some OAL-related APIs. So we go through a number of OAL-related APIs, and again, when it comes to these API tables that we're supplying in the material, it's not really necessary to go through every API and explain how every API works, but you might want to pick out a few and talk about how those work. Of course, if your students are very much on the beginner level, they're probably not going to remember any level of detail that you tell them about a specific API anyway. You really want to just give them a feel for how modular and the approach that Microsoft has taken in building an OS and building, in this case, an OAL. Basically, they have to supply a number of OAL functions to satisfy the externs for the for building a device, and so you kind of just give them that feel. But if you do have developers, if your class it has some more experienced developers, maybe they do have some specific questions about an API. So you can just use these as you see fit based on your audience. Some more OAL APIs, and then finally we have some OAL ioctl codes. Okay. Then we talk about the files that exist within the BSP. Now, some of these you maybe have already gone through when we were talking about the different file types. Maybe you use these files as an example. I think at this point, if you reiterate that, then things start to come together probably fairly well for the students. So probably be a good point to just reiterate that using File Explorer. Okay. And the next slide here is a lab. It's on registry initialization, and it has to do with precedence of registry. with how the registry files are used. Okay, so then the next topic is creating a BSP, and here what we're really talking about is we're talking about what are the real steps to getting a BSP working, and the first step is always to clone an existing BSP. Now, that may mean that you've got a BSP from a third party and you clone that. It may mean that you've taken a Microsoft BSP and cloned that. Very seldom does it really mean that you're creating a BSP from scratch. So it could be BSPs that are included from any source. It could be that if you wanted to create a BSP from scratch, what you'd really do is you'd still clone an existing BSP for the right processor architecture, and you would pretty much remove all the contents and then start adding in your functionality. Very seldom, again, would you create a BSP from absolute scratch. Okay. And then, of course, modifying files as necessary, which include all the files that we've talked about already, as well as drivers, which we'll talk about in the next section. And then the comment here, get Kittl working early. You definitely want to take advantage of the tools that you have for debugging, and Kittl is the mechanism that your students are going to use to debug their devices. So talking about getting Kittl working early is a good thing. Okay. And then finally, of course, you're going to test your BSP. So those are the basic steps for building the BSP. Now you're going to move into another lab, and that's adding a new IOCTL to an OAL. This is where they actually go into the OEM IO control and add their own IOCTL to the OEM IO control, and actually see an output message from that when they boot their device. Same lab as before. Again, all the labs are basically the same as they were before. Okay, so then we move it into the review slide for the board support package, and then we're going to move into the next topic. So take any questions from your students, and then move. Next topic is device drivers. Probably for many audiences, at least in my experience, it's been that this is the topic that they care about probably more than any of the others. But here. You are going to talk about an overview of device drivers. You're going to talk about the user mode driver framework, handling caller buffers, loading a stream driver, debugging device drivers, and then you'll finish up with a review. They're going to do two labs. One is integrating a device driver, and the other is debugging a device driver. So I'll go through this fairly quickly and just talk about the points that change. First, introduce what a device driver is, and simply a software component that abstracts the functionality of a physical or virtual device. Then you want to give your students an idea of what drivers are included from Microsoft. In other words, what do they have to provide versus what does Microsoft already provide for them. So here we just simply list a bunch of the drivers that are supplied with out of the box with Windows Embedded CE. And of course you can take them to all these locations here and show them different drivers that are available, public common node drivers, public common node CSP, and then of course all the platform drivers folders. Okay. Then we talk in continuing on with an overview of device drivers, we talk about the different ways that drivers are classified, layered versus monolithic, native versus stream, user versus built-in, user versus kernel, built-in versus dynamic or installable, and then finally driver classes based on the driver family. So different ways to classify drivers, and we have slides that go into each of those topics. This material is basically the same as it was before. So we talk about layered versus monolithic drivers, and talk about hybrid drivers. Some new graphics for the drivers. So here's a graphic on native drivers and what native drivers look like in the system. So using the same color scheme, we have hardware here in green, and then we have Microsoft components and, of course, the OEM components. And that's native drivers. That's an example of native drivers, obviously sitting under GWES here. And then we show the same thing, but we show it using Device Manager for Stream Interface drivers. Then we have graphic that's fairly consistent with the previous graphic for stream driver architecture and how stream driver architecture works within Windows CE. We have file naming, stream driver file names, and how stream drivers are named within Windows CE. Same information as was there before. So we talk about legacy namespace, we talk about device namespace, and we talk about bus namespace. Bus namespace. Okay. Then we talk about device driver entry points. So we talk about the 12 entry points of device drivers. And one of the things that I typically will do in classes is it just so happens that drivers get mentioned various times during the class, and I try to reiterate what these 12 points are to get everybody, these 12 entry points are, just to get everybody thinking about, okay, how logical it really is that these 12 entry points exist. You can talk about the pre-DNet and the pre-close from a standpoint of how they were added a little bit later and what the purpose of those two functions are. But you really want to probably talk about every one of these functions in detail. So while it's listed in that consistent table format, this is a time where we actually do want to talk about every function in pretty deep detail. You might even want to relate that to a real driver. Here you see that not only do we have a description, but or the function name, but instead of a description, we actually have when it's called and typical driver operation, what the driver does when this function is called. Okay. Then we have how do you implement a stream driver, and here we're talking about the simple points of selecting a device file name prefix, implementing the entry points, creating a def file, and creating registry values that are necessary for your driver. Then we use the same graphic that we used when we talked about architecture, and in this graphic what we're doing is we're basically trying to provide a system view to show where drivers actually fit within the system. And the two things that you really want to point out here are the drivers that sit in kernel mode, and of course the drivers that sit in user mode inside of the inside of the hosting process udevice.exe or multiple instances of udevice.exe if they're not grouped together. Okay. Then we have a slide on kernel mode drivers, talk about some of the specifics for kernel mode drivers, talk about some of the specifics for user mode drivers, nothing really new here. This is the same as 6.0, so nothing really new. We talk about the user mode driver framework in 6.0, and it's the same as it was in 6.0, so nothing new in that regard. We talk about how user mode drivers are loaded. Again, just a graphic. It's basically the same as before, but it's consistent with the new formatting. Then we talk about the reflector service and how the reflector service is used to make user mode drivers act as kernel mode drivers from application perspective. Then we take a look at user mode driver host process and how it's what the connection to the registry is there. So the important things to point out here are the user mode driver process udevice.exe, the processor groups, and then how a driver might actually have a user proc group setting, as you see here, defaulting to group number 3. And then the other thing to show here is that the flags does have the settings for loading as a user proc. Okay. Oops. Let me get synced back up here. Okay. All right. Now the next slide is bib file issues for user mode driver framework. Just talk about those typical bib file issues. Nothing new there, same as it was before. Use the Q flag to fix up both places, fix up the driver for both places. If it's loaded in the module section of a bib file, if it's in the file section, then you can tell them that. Tell your students that if it's in the file section, then it's loaded dynamically by the OS at runtime, so it doesn't matter. Okay, restrictions for user mode drivers, and so here we talk about the restrictions that exist. This is the same information that we had before in regards to user mode drivers. Careful use of kernel mode API. Some drivers must run in kernel mode. Same information that was there before. Kernel mode driver restrictions. Here we talk about the UI proxy and how you can't use a UI directly from a kernel mode driver. Okay, then we talk about handling color buffers, and in order to talk about that, we have to talk about the 5 terms that are commonly used when we talk about handling color buffers, which would be pointer parameters, embedded pointers, access checking, marshalling, and secure copy. So here we actually, the screens have changed quite a bit, but the information's the same information. Talk about terminology and show an example and correlate that to the actual terminology. Then we have a slide on access checking, so we now take each one of those terms and talk a little bit more about each one of them. Same information that was there before, nothing's changed in this regard for R2. Talk about different marshalling methods, direct and copy and alias. Talk about, let's see here, synchronous access versus asynchronous access, and the difficulties in asynchronous access and the things that can happen from an asynchronous standpoint, but nothing new here. Handling secure copy, talk about secure copy and why secure copy can be used to prevent, or how secure copy can be used to prevent any modifications to parameters that were passed in by an application. In other words, more of a security issue, hence the name secure copy. Talk about APIs, CE open and close color buffer. Okay. Talk about CE alloc asynchronous buffer and free, duplicate and free, and then review the APIs in the standard table format. So no new information here, really just slides to talk about the different APIs in some detail, and then a slide to just recap and provide one point of quick access to what the different APIs are that have to do with handling color buffers. Okay, the next topic is loading a stream interface driver. So you want to talk about how the drivers are loaded using registry keys, how that process is controlled by registry keys. You want to talk about the API Activate Device EX. And you do want to talk about the loading requirements that are supported for automatic drivers that are loaded automatically at boot time versus drivers that are loaded dynamically via plug and play by another bus driver or by an application or another driver even. Talk about the registry keys, DLL, prefix, order, index, iClass, and flags. We actually give a breakdown of what the different flags are that are used. One of the things I do like to point out on this slide is the importance of adding an index, and talk about how not supplying the index causes enumeration of a specific prefix, and how that can, depending on the circumstances upon how the devices are enumerated, could actually change at runtime. So providing the index actually fixes that so that you potentially don't cross those kinds of problems, but definitely probably want to point that out. The other thing in the flag section, the thing I probably point out more than anything else is the user mode process flag that basically says load the driver in user mode. So here is that flag. Okay. Next slide. Talk about typical device driver registry settings for things like bus information. This is the same information that we had before, but we have bus information, we have memory and I/O window information, we have IRQ information or interrupt information, including ISR handlers if you have an installable ISR. Then we want to talk about bus drivers a little bit, what bus drivers are and examples of bus drivers in the system. Talk about busenum.dll and how it actually is kind of a driver that looks at the registry as a bus. Okay, Let's see, device manager process for loading drivers at boot. This is just a registry example to kind of show the important information about how Busing is loaded. So this registry just gives you this screenshot gives you a simple way to talk about that process. Looking at businum.dll from a built-in standpoint, and also looking at root key to end up getting to businum.dll. Okay, this just looks at some sample registry data for a driver. In this case, it's the backlight driver. Then the students are going to do a lab on integrating a device driver. So they're going to actually integrate a device driver into their training BSP. Then we're going to talk about implementing Kiddle, doing a debug build using the kernel debugger, and using the capabilities of the kernel of the Visual Studio environment to do things like look at breakpoints and set breakpoints and view call stacks and watch variables and those kinds of things. In regards to debugging device drivers, one of the big components, or one of the big services, if you will, for messaging from drivers is the debug message macro or debug zone implementation. And so you're going to take your students through that debug zone implementation. It's not different than it was before. Probably one of the important things to take away from this slide is really how release directory modules works. Okay. Hold on for a second. I'm going to pause, and I'll be right back. Okay. Hopefully that fixes that problem. Okay. Now we're going to talk about debug messages. So let's see, where did I leave off here? Oh, I was saying that the flat release directory, loading a driver from the flat release directory, talk about that and how important that is, and how it can actually be to their advantage for drivers that don't have to, that can be unloaded in the system. Okay? Combining release builds with the kernel debugger, as they're doing in the labs, is always a good approach, and so you can reiterate that with the slide. Talk about how release builds actually create a much smaller image, and how release builds provide a quicker boot time, and all those kinds of things. A more real world experience. Talk about debugger issues. For example, you can't set a breakpoint. One of the ones that I like to mention here that I see in just about every class is that somebody has the device attached to Platform Builder at the same time they're trying to build an image to run a make image phase. The make image phase will not run if it can't write to an nk.bin. So while it's not directly related to breakpoints, it is related to issues that they would have in problems that they might see. For some reason, that slide just reminded me of that point. In regards to breakpoints specifically, one of the ones that I typically do see in a class is that someone will build something in release mode, try to set a breakpoint in it, and then really not see why that breakpoint moves to a different line. But what's really happened is the release build, because it's optimized, if you try to set a breakpoint in source, that source may move based on the optimizations of that code. Okay, let's see. So here we're talking about compiler optimizations and release build affect the debugger. No new information really here. One of the things that you can let them know is that if they have problems following the code because they did do a release build, then a lot of times switching to a disassembly view fixes that problem, although the code might be much harder to read since it's now going to be disassembled code. But now we are going to talk about the debug message service, debug zones, and how debug zones are created. This information is the same as it's been for quite a while in Windows Embedded CE. Nothing new here. 16 zones per module. Debug zones have to be registered with the debug subsystem in order to use them dynamically. The macros that exist are the same macros, debug and retail macros for messages and for LEDs. The other thing to point out here and to reiterate is the fact that they can do a ship build, which actually turns off retail message as well. Here we're showing an example screenshot of defining the debug zones. We talk about how to control those debug zones from various places. For example, in the structure itself, in the debug param structure, they can set a mask. You can remind them of that. You can talk to them about how they can override that default using the HP local machine debug zones in the image, or on the development PC, on their host PC that's connected through Kittle, they can change it through HP current user Pegasus zones, which is really good if you're trying to change zones that need to be changed while the device is booting. For example, maybe you have a problem in an Atapi driver and you want to change the zones in that Atapi driver, but by the time you could actually get to the interface and change it, you wouldn't be able to do that, so therefore you want to find the easy way to change it. Well, if you have a Kittle connection, super easy, just change it from your host system. And then you want to talk about how they can change them dynamically using the target control window or the target CE debug zones. Target control window using the ZO command. Hopefully they've already seen that because they experimented with the target control window during a lab. Okay, the debug message service, you want to tell them that they have to be registered with the debug subsystem, as we said. Nothing really new here. We get you'll notice there's probably quite a few more graphics than there used to be. Try to supply the graphics as talking points when at all possible, or at least quite often. A little slow here. Okay, so now we talk about the different macros that can be used in regards to debug zones. One of the things you probably want to point out is that macros are used extensively for all of this, for the implementation of debug zones. You probably do want to go through each of these macros and explain how each of these macros works. I think it's a good idea to look at this sample code. So going back to the previous slide, you can see we use the WCE stream VT CPP file from Bluetooth to actually show the debug register call. I think it's a good idea to open up a file like this and actually look at the implementation, any driver that implements debug zones, and look at the implementation. This driver would actually be a good one to use. Okay, so you're going to talk about those macros, and then they're going to do a lab on debugging a device driver, and they're going to use debug zones. So that's the final lab of module number 7. Again, basically the same information that you had in the previous class, reformatted and cleaned up a little bit. Okay, so then you're going to do a review of Module 7, and next topic that we have for review is, or next module we have is customizing the OS design. So because we fall on an even page, we have an extra slide here that's left blank intentionally, and then we move into the title slide. And finally, the first presentation slide of the module, which falls under the course outline format again. So we've got the course outline format with the basic street signs here, and now we're moving into module number 8 of our 10 modules. Okay. So in customizing the OS design, we're going to take a look at the catalog. We're going to talk about adding an item to the catalog, shell options, replacing the standard shell with IE shell, SDKs, and exporting an SDK. Same topics as we basically had before. Nothing really new here again. Okay, so what is the catalog? We want to talk about what the catalog is and how it is like a database. I mean, we even say many times we even say database. Oops. Many times we even say database, but talk about how it really has to do with file structure, and you'll expand on that a little bit further as we move to the following slides. So. Talk about how the catalog items view is used. They actually walked through this in their very first lab when they were building their OS design. But now you're going to make sure that all of those points that they've either run across or have experienced in a lab are definitely setting in. So you want to explain how the catalog items view is used. You want to talk about how the properties for catalog items are used. Talk about reasons for inclusion dialog, and how when you open that, it actually makes it appear that you're trying to remove something when that may or may not be the case. So explain how that's used, same as it was in 6.0. Talk about how to open a catalog item file for viewing or editing. Make sure that they select Platform Builder catalog files from the files of type drop down in the Open File dialog. Once they open a file, then they'll actually see the graphical user interface for editing catalog files, which is really just a tree. And now for every item that you click on within that tree that you see here on the right-hand side, the properties comes up, and it's context sensitive again. So depending on the type of item you click on, you're going to see different properties. But you can talk about how they can use that graphical editor to edit the catalog and how they'll actually do that in a lab. Okay, you can talk about how they can actually edit those catalog files in XML format if they want to, because that's how the files are actually stored. It's called a PBC XML file. It stands for Platform Builder Catalog XML file. Okay. So to create a new catalog file, they can select File New, and you basically show them the steps here for creating a new catalog file and where to put the file so that it's recognized as part of the database, if you will. Okay. One of the things I do like to point out, let me go back to the slide. One of the things that I do like to point out is that the third-party directory, if it's not going in your VSP, generally the preferred place to put anything for third-party is under the WinCE root third-party folder, so you definitely want to point that out. They actually do that in the lab, so they'll get the point from you and also from the lab. Talk about exporting a catalog item from the catalog and how to do that. Makes it using this XML format. This is actually a very simple process, so you can talk to them about that. Talk about validating a catalog file or the entire catalog. Probably want to talk to them when they do that. You probably do want to talk to them about how some of the files may generate errors, and they really need to evaluate each of the errors and understand the merits of the error and whether it's really a problem or not. Okay, then you're going to have them add an item to the catalog in a lab. That's lab 8-1. Next thing to talk about is going to be shell options. So you talk about installing a custom shell, shell shortcuts, target startup folder, and the typical welcome application. This information is really the same information that they had in the past. Talk about what comprises a shell. Talk about the shell architecture in Windows CE. Talk about how any application can be used as a shell. Talk about how to access the shells in the catalog item view. Talk about the standard Explorer shell that exists on Windows CE, providing that familiar look and feel, which they've actually already seen in any of the labs that they've done. Then you want to talk to them about the command shell. The important thing here, I think, is probably that the command shell can actually be redirected to a serial port using registry settings. And so in the notes, we actually provide them the registry settings that they would need. Talk about the passcommand shell as a sample for developing a custom shell. Talk about how any application could be used as a shell, whether it's a native application, a managed application, browser-based application, even an application that doesn't have a display, and many examples of custom shells. So you could list as many as you can think of there, but there's tons of examples of custom shells. Talk about how the shell is loaded at boot time using HT Local Machine and NITKey. So here they can see the example where they're launching myshell.exe. They're actually going to do this in a lab, so I think we'll get the understanding there. So it's launched using the launch key. Make sure that they understand that they have to call signal started and how that works, how it's passed to them on the command line, the actual parameter that they need to call signal started with. And you want to talk about shell shortcuts. No new information there. Talking about the startup folder and how they have to create a startup folder if they want one. Talk about sample application code for some type of a welcome application. Maybe actually checks for calibration data. If that calibration data doesn't exist, then they would they might cause calibration to occur by calling the API touch calibrate. This is just giving that example. Okay, so then after discussing the shell, you're going to let them do a lab on replacing the standard shell with an IE shell. One of the things that I kind of like to point out here is that while many devices from a primary user interface don't want the Explorer shell, it's very possible that during development you do want the Explorer shell, and how a lot of times we'll put the Explorer shell in the image and launch the Explorer shell on demand using maybe some kind of a funky, button press sequence or something like that. Okay. Next topic is the SDKs. Creating an SDK with CE 6.0 R2 is no different than with 6.0, but you can talk about what an SDK is, and then of course how the SDK is actually created. Talk about how it ends up being just an MSI file that they can then install on any computer that has Visual Studio, and then let them do a lab on exporting an SDK. Okay, so that wraps up module number 8, and you'll do that with the review as you do with all the modules. And now we're going to move on to module number 9, which is application development. Again, application development is pretty light in this course. It's not designed to be an application development course, but more of an OS development course. But we do have a section on application development to talk about some of the fundamentals. And we have to talk about the different application development options. We have to talk about native and managed code development. And we're going to let the students do a lab on developing and integrating a managed application. So be sure, before they do that, before you set the computers up, be sure to check out the README file that I put with the files on the training server, so that way you make sure that they have the right files that are needed for making the lab work smoothly. Okay. For application development options, you want to talk about the tool options, the language options, and the API options. None of this has changed since 6.0, so we really have the same options that we've had in the past. Here's a little table that shows, and the PowerPoint catch up here. Here's a little table that shows the language API framework options that they have. And so for developing the different pieces of the OS, from OEL, driver services, application shell, and internet client services for the different languages, C#, VB, C++, and Assembler. Another point to make on that slide is how C# and VB are both managed, and then Assembler and C++ would be native. Talk about how there is no managed C++ code in Windows CE. Then we talk about native applications and the aspects of a native application. Again, none of this information has changed from 6.0 to R2. talk about the different native code frameworks that exist, and here you can talk about how those frameworks actually ship with Visual Studio. Then you're going to move into managed application development. So here you really want to kind of give your students a feel for why are managed applications different than native applications and that kind of thing. And so here we talk about the different aspects of managed applications, and it's kind of a good thing to correlate the two, managed and native. Talk about the managed application development components for you know, talk about the Compact framework, the Common Language Runtime, and the .NET class libraries. Talk about how it's a subset of what's available on the desktop. Talk about how you can use VB, .NET, and C#. And then you're going to let them do a lab on developing and integrating a managed application into the OS design. So, the lab definitely is targeted at more of the OS-related issues. For example, in integrating a managed app into the OS design is really nothing about creating the app. It's more about how do you get that built into your OS design. Okay? So now you move on to a review of Module 9. Again, a really pretty short module. The lab's not too short, and you can actually spend a lot of time in the lab, you know, letting the students investigate things and that kind of thing. Okay, so now we're going to move on to module number 10. And module number 10, we're going to talk about testing and verification. So here we're talking about the Windows CETK. And our first presentation slide will be our normal course outline slide, testing and verification. Okay, so we're going to talk about Windows CE Test Kit, other test utilities, and then we're going to let them do a lab on using the CETK. Talk about what the Windows Embedded CE Test Kit is, no new information there. This information in this section is pretty much the same as it was in the previous course. I think the difference is we've added quite a few more graphics to show what different tools look like and those kinds of things. But it's basically the same information. So talk about an overview of the CETK, different aspects of the CETK, nothing really new here. Show the architecture of the CETK in the system and how CETest.exe runs on the development workstation, whereas having the CETK, having all the tests run on the target and collect the test data locally rather than being attached. So you can talk about that. Here we provide the details of CETest.exe for running on your host PC. Here we talk about the context menu allowing you to set the command line for running each individual test. Talk about client-side and how client-side is used, how client-side can connect to the desktop. So we talk about the invocation options that are available there. Talk about Tux.exe, talk about how it's the process that hosts any of the test DLLs. Basically, it provides the execution engine so that the developers, your students, can focus on the specific things that they want to test and their actual test code. You can talk about how it can run standalone, like I said earlier. Then we show the Tux command line parameters, and then we show another slide on command line parameters that are available if you have the logging engine present, and also finally one there if you have toolhelp.dll for setting a timeout. Do talk about the logging engine and how the logging engine is used. Same information as before, nothing new here. Talk about test source code and where the test source code exists at. Talk about how to create a new Tux test from a skeleton or from existing source code. Talk about the log files that are generated when the tests are run and where they're stored at and how they're sorted. And here we just show the basics of a log file. So we actually show the log header and the actual test results for a test case, and then we actually show the footer of the log file. I think it's a good idea to show them a real log file, through Internet Explorer and Visual Studio, that kind of thing. Just navigate to a log file, show them the log file, and explain the different aspects of the log file and what it means. Talk about result codes, nothing new here. And then talk about just a slide on where to get more information on CETK. And now we're going to talk about the other test tools that are available within the CETK. So first slide here just shows how to get to those other tools. I've actually been asked quite a few times how to get to those tools. So here we show that. And now we're going to show each one of the tools. So if you look at that menu that we bring up there, you can really use that as a segue to the next slides. You got Application Verifier, CPU Monitor, Resource Consumer, and Windows Embedded CD Stress. And so we're going to take a slide on each one of those, talk about Application Verifier and how it uses shims. Talk about the CPU Monitor and how it's similar to perfmon. Talk about Resource Consumer and how Resource Consumer can be used. Talk about how many times they might want to do this kind of thing in their own application if they don't want it to be in a separate process space. Depends on what they're really trying to test. Talk about the stress tool. Then we want to just mention some other test utilities that are available in Windows Embedded CE. That would include the scripting tool for testing accurate scripting without the use of a web browser, and also talk about the print screen tool for saving screenshots instead of using a tool like Zoom. Then we're going to do a lab on using the CETK, and again, the same lab that we had in the previous 6.0 class. And then finally, we're going to review module number 10, and really at that point, you're pretty much through the material. We just have a couple extra slides that provide a little bit more information. We chose to cut this down quite a bit from a standpoint that really from a licensing standpoint, they really need to talk to their distributors, and so we talk about two things here, licensing and developer resources, and both of these topics warrant a slide. So for licensing, we talk about the process and talk about the runtime license assessment tool. That's from a developer standpoint, that can be something that is important to teach in this class. From the standpoint of the actual licensing itself, I think that pointing them to a Microsoft Embedded Authorized Distributor is the way to go. Okay. Then, and maybe taking any questions that you may or may not be able to answer, depending on whether you are a distributor or whether you have that kind of knowledge or what. But your students are engineers, so they may or may not have questions in that regard. Then we want to talk about how to get to other developer resources and what those resources are. And because those resources do change, we decided not to really put a lot of effort into providing an exhaustive list in the actual class materials themselves, but rather to point them to the Embedded Development Center on MSDN, where all of that information exists and is updated more frequently than this course is. So that would include, access to MSDN, community source projects, as we mentioned earlier in the class, news groups, additional training for third parties, and blogs, charts, webcasts, the things that you see listed here. So, just a good slide to end with, and let everybody know that there's a good landing page for access to more information. And then finally, there's one last slide, and I just added this slide because it used to be the introduction slide with a little Sudoku puzzle for them. and just a slide to kind of end with to say thanks for attending. At this point, you probably do want to remind your students about the evaluation process and about how they would get their certificates and that kind of thing. You know, take closing questions, have closing conversations. You know, I think every class ends a little bit differently, but this is the slide that you actually close with, assuming that you don't have a follow-on presentation. So I just want to recap. So this training that you're viewing right now is a train the trainer session. So I've tried to make the assumption that everybody understands Windows CE in pretty good detail here. Everybody's already been through a train the trainer session on 6.0, and maybe even some have been through 6.0 R2. But I really wanted to you know, take you on a tour of the new material, give you a feel for the flow of the new material. Try not to spend too much of your time. I think we're going to go for about 3 hours here, and that's it. But wanted to tell you what our goals were in updating the material, and kind of just let you know any pointers and things like that. If anybody has any questions after viewing this material about the class and that kind of thing, you can for sure feel free to email me. And you can email me at rwmoore@a7eng.com, and I'll be happy to either get your question answered or answer it myself if I can. Other than that, maybe we could just simply review the goals for the class so you can see how we met those goals with this material, and then we can be done with this presentation. So kind of just recapping the goals. The basic goal was to use the base material that already existed, so that instructors don't really have to modify too much their way of teaching, but at the same time to have some fresh material, to have any updates that have taken place, to correct any errors that existed in the material, to provide a consistent look and feel to the material, consistent theme throughout, consistent theme for graphics, consistent theme for text, those kinds of things. The idea behind creating an instructor manual and how you can actually add and modify those materials as you see fit, how that the instructor manual is created like the student manual is from the slides. Make sure that if you have a copy of the PowerPoint presentation with the instructor notes in it, that when you run the macro as the README file explains, that you save off a copy of the original PowerPoint presentation, because the notes are going to be removed from it. The instructor notes are going to be removed from it when you run that macro. Let's see. Other than that, I think that's pretty much it as far as the goals for the material. I thank everybody for watching the material, and again, if you have questions, you can email me at rwmoore@a7eng.com.